Hi everyone. In this video, I would like to discuss classification of nanomaterial. According to Professor Richard Siegel, nanomaterials are classified into four types. The first one is zero-dimensional nanomaterial. It means that nanomaterials are less than 100 in all the three dimensions. Means they have not grown beyond 100 nanometer in all the three dimensions. Maybe they'll be in the form of spherical particles. And second type is one-dimensional nanomaterials. These are the materials which are less than 100 nanometer in any two dimensions. Okay. In one dimension, they have crossed they have grown beyond 100 nanometer, and they are called one-dimensional nanomaterials. And third one is two-dimensional. These are the materials they are less than 100 nanometer in one dimension, and they have grown beyond 100 nanometer in any of the two dimensions, either length or breadth. Maybe the thickness will be less than 100 nanometer, and the length and breadth they go beyond 100 nanometers. The three-dimensional nanomaterials, these are actually the aggregation of any of these above, 0, 1 or 2-dimensional materials with greater than 100 nanometer in all the three dimensions. However, that particle will have either zero-dimensional, the combination of zero-dimensional, or the combination of one-dimensional, or the combination of two-dimensional materials. Overall, it will be a greater than 100 nanometer in all three dimensions, but it will have the aggregation of nanoparticles of 0, 1 or 2 dimension. Okay, let us look at this picture. The first one, the one-dimensional, zero-dimensional nanomaterials will be in the spherical shape, and one-dimensional nanomaterials will be in the form of wires or rods or tubes, and two-dimensional materials will be in the form of sheets. Okay, like this, and 3D they will be in the form of the combination of a number of cubes here. And this is another picture showing the classification of 0 to 3D. 0 means they may be spherical, and even in the sphere, it may have some other small particles like that. We have coarse nanoparticle, we have encapsulated hollow sphere, we have composite nanoparticle. In one-dimensional, the wire can have other zero-dimensional particles embedded, but overall it is a one-dimension carbon nanotubes containing some other material which are in zero dimension. And the coaxial nano wire array, the composite nano wire array, all these are coming under one-dimensional nanomaterial. In two-dimensional materials, they will be in the form of sheets. Okay, they grow beyond 100 nanometer in two dimensions. They may be in the form of plates, belts, okay, like that. And 3D, we have the combination of this one-dimensional mesophorous composite electrodes used in some batteries. And this is also another electrode embedded with some other nanoparticles inside. And this is a 3D electrode, three-dimensional electrode made up of one-dimensional and zero-dimensional material. Let us look at some of the real particles. For example, zinc oxide, which has grown in all the three dimensions, and the 10 images which are displayed here are the real pictures of zinc oxide. Okay. These first two figures are the examples for zero-dimensional zinc oxide material. And look at this, the size is less than 50 nanometer in all the dimension, and they are spherical in nature. So therefore, it is a zero-dimensional material. And this one, this is actually a one-dimensional material because they have grown in the form of wires. And this is also made up of n number of one-dimensional nanowires. They are aligned in a symmetrical manner. We call this structure as hierarchical architecture. And look at this. This looks like artificial grass, but it is actually zinc oxide, which are grown on some substrate. And this is an example for one-dimensional material. zinc oxide. This is another picture showing the zinc oxide tubes are grown on some substrate. Okay, this is also an example for one-dimensional material. And this is another one. This is zinc oxide flowers in which is made up of one-dimensional nanotubes, zinc oxide tubes. This is the flowers. If you expand that 10 micrometer to 1 micrometer, if you zoom it, you will see the nanotubes which are arranged in the form of flowers. Okay, look at this. This one. This is also one-dimensional nanomaterials which are grown on some substrate. And this is side view, and this is the top view of zinc oxide. Okay, this is look at this is all one-dimensional zinc oxide nanotubes, 100 nanometer in size. And this is an example for two-dimensional zinc oxide sheets. They have grown more than 100 nanometer in 2 dimension. And the thickness will be less than 100 nanometer. And these are the zinc oxide nano petals. These are all 2-dimensional. Hexagonal plates, nano flowers, petals. These are zinc oxide nano sheets and zinc oxide nano flakes. These are all coming under 2-dimensional nanomaterial. Okay, next step. This picture is showing the real image of zinc oxide which are grown, and it looks like the flower. Okay, this is made up of one-dimensional nanomaterial, but overall, if you take one bunch, it is actually 3D, more than 100 nanometer in all the 3 dimensions, but it is made up of one-dimensional zinc oxide material. Okay, each bunch is 3D. And each bunch is having n number of one-dimensional zinc oxide nano wires. Okay, this is another example for 3D material containing one-dimensional zinc oxide nano rods. This is the real zinc oxide which has grown. Look at this beautiful picture. This is also 3D material made up of 2-dimensional sheets which are oriented in the form of flower. Look at this. This is also 3D material of zinc oxide. This is a wonderful zinc oxide material. Zinc oxide with wonderful morphology. This is an example for 3-dimensional material. Okay, look at this picture. How the zinc oxides have grown. These are all hierarchical zinc oxide structures in the 3 dimension. These are all magnified images of same zinc oxide. You can see the hexagonal hole inside each the tube shaped zinc oxide. This is a 3D material, wonderful 3D zinc oxide. And look at this. The zinc oxides have grown in the form of thread or entangled among each other, one after another. Okay. This is another zinc oxide material, an example for 3D material. These are all wonderful morphologies of 3-dimensional zinc oxide material. This is another example for zinc oxide. This is just colored image, but still it looks like a garden, zinc oxide garden. And this is they have just this is actually natural forest, and there's similar in the same way they have prepared zinc oxide at nano level. So this is a nano tree and this is a normal tree. This is the natural forest and this is the zinc oxide forest. This is the beauty of the morphological morphologies of zinc oxide, which are grown by varieties of in the form of varieties of shapes, and each morphology is exhibiting different properties. That is the beauty of this nanomaterial. So this is the classification of nanomaterials and examples. We have 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional. We have another type is quantum dot is also there. This is a quantum dot means it is less than 10 nanometer in all 3 dimensions. Any material which is less than 10 nanometer In all the three dimension, it is called quantum dot. Similarly, quantum wire, it is less than nanometer, less than 10 nanometer in 2 dimension. In 1 dimension, it is greater than 10 nanometer. And quantum sheets are also there. It is less than 10 nanometer in thickness. So you enjoyed this classification. If you like, please like this video, comment it and share it to your friends, and please subscribe for further updates.